Filecoin aims to be kind of a robust foundation for humanity's information. And so it wants to store and be useful in those areas. And we actually, literally have groups who are like, great, I'm going to a very simplified version of data availability. I'm like offering data availability to data availability layers because they're doing like, all sorts of proof related things on top of the data. And it's like, well, but you just want to make the data available, right? To anyone who wants to fetch it. Like we can do that. And we can do that for long periods of time, much more than 7 days of your proving window so that you make sure that anyone can also use that as an RPC to fetch data or to index data and build their applications on top of. And so this is kind of what Basin is aiming to do for DePIN nodes and networks so that all of their DePIN data has a decentralized home for making the data available. And you don't end up with someone actually having a centralized point of failure because they're running the AWS account that everyone loads their data to. But if that credit card went down, suddenly all of your DePIN nodes would suddenly be being slashed because their data isn't accessible and your whole network value goes away.
Hey everyone, this is Sina with another episode of Into the Bytecode. My guest today is Molly Mackinlay, the head of engineering, product, and research development at Protocol Labs, and more recently the CEO of FilOz, an entity that spun out to focus on core development and public goods. Molly's been a technical leader at Protocol Labs since the very beginning, working on IPFS, working on building the Filecoin storage network, building the retrieval mechanics and incentives, and more recently focusing on bringing compute to the network with the Filecoin virtual machine and scaling solutions like IPC. So in this conversation, we talk about the progression of Filecoin from the beginning and how the different pieces of the puzzle and the ecosystem fit together. We talk about how folks are using the network today, like how, for instance, CERN, the particle accelerator in Europe, is saving their experimental data onto the network. We talk about how the network is going to scale from here and the IPC framework, which is similar to layer 2s on Ethereum. It allows each of these networks to have their own consensus mechanism and to relate to each other in parent-child relationships recursively. And towards the end of the conversation, we also talk about some personal interests like neurotech and how it might impact how we think and learn. I do want to say that this podcast is for informational purposes only. It's not financial advice or recommendation to buy or sell securities. And with that, I hope you enjoy. Into the Bytecode is sponsored by Privy. One of the biggest problems we're grappling with as builders working on crypto-enabled applications is how to make the right trade-offs between user experience on the one hand and security and privacy on the other hand. How do we promote self-custody and ownership while letting the application shine rather than the crypto behind it? So Privy plays an important role here. They provide simple onboarding so anyone can connect to your app easily by allowing them to sign in with an existing wallet or by making it easy for you to provision a new self-custodial wallet for them, linking to social logins like Google, Twitter, or Discord. I personally have faith in Privy because of the team. Henry Stern, who's one of the co-founders, was previously on an episode of this podcast, so you can listen to that conversation for more of a deep dive. And he and his partner, Asta Lee, have been thinking about data privacy and security for a long, long time. And you can see this in the level of thought they're putting into the product. So if you're working on a new product and thinking about how to reach a wider group of users without compromising on either user experience or privacy and security, then I encourage you to check out Privy at privy.io. Okay, so I thought a good place to start might be I've heard you describe Filecoin as three stages of a project that are coming together. The first is storing data, second is retrieving data, third is doing compute over data. So maybe as a launching off point for this larger conversation, one, like, why is this a problem that you care about at all in the first place? Like, why does data matter? And then how do you think about what Filecoin, or maybe more accurately to say that the universe of Filecoin related projects, like what they're kind of oriented at accomplishing?
Totally. I think we all live and breathe data and applications that are connecting us online digitally to do all of our work, all of our connected, all of our collaboration these days. And so, my background from working in tech, working in education tech was especially relevant when I was like, oh, wow, when we have digital systems that are connecting people, they need a lot of agency over how their data is being stored, how they can exchange it with others, and, putting central intermediaries in between all of that who then own all of your data, or you can't connect with the people you care about without having to exchange your data through them. So that you can't, send something to someone next to you. It's a key pain point. You saw it in schools with bad Wi-Fi where they couldn't turn in their Google Classroom assignment to the teacher, literally sitting in the front of the classroom because their Wi-Fi connection to some Google data center somewhere was down. And like, oh, I can't turn in my homework today. I used to be able to do that when it
So
was
maybe
made of
maybe to
paper.
go on a bit of a tangent here. So
Yeah.
you worked at Google on Google Classroom,
Mhm.
and were you working with schools that were kind of off the grid or didn't have access to the internet?
We
Or
Google Classroom, really capitalized on the large scale education adoption of Google Docs and Sheets and Drive and things like that. So we got very large scale very quickly. I think within the first couple of months, we had over 5 million students and teachers using Google Classroom. I'm sure now those numbers are like, definitely tens of millions. Who even knows how large? Um, but the trajectory that we were just working with whoever wanted to adopt this, students and teachers. We went and visited classrooms. This is like we visited Thailand. Thailand had better internet than many schools in New Jersey that we visited right next door to the Google New York office. Just, many schools don't have that sort of connectivity. They have these like brick cinder walls and
it's like a
ancient
perfect Faraday
devices.
cage.
Exactly. And so, to have all of this setup time or all of this overhead time for people to just exchange data and information. And one of the things that caused me to realize and jump into the whole IPFS community 5.5 years ago was there's this huge opportunity for the internet to work differently, to empower people to actually own their own data, to exchange their data peer to peer instead of having to go through someone else. And I think especially now in the age of, you know, larger and larger AI models consuming even more data about us as individuals and about the way that we interact with applications and computing platforms. That data is actually what powers these huge economies, these huge businesses that are monetizing that data, whether it's data that they can then use for advertising or data that they use for services that they're selling back to us. If we lose access and lose control over our data, that's a key economic output that we're now not able to benefit from, not able to own. And I think that's one aspect that is really important. The preservation aspect is another good one of like, hey, I care about this data. All of my life is like my text message history and my photos library and my email threads. And like, that is so much of the work that I do and the human relationships that I have and how I make sense of the world through looking things up on Wikipedia every time I don't know what someone's talking about. And if we lose access to that data, humanity suffers and our productivity and our capabilities and our relationships suffer because all of that is now online and connected. And so we need robust storage systems that are highly resilient, that have storage nodes all around the world and that can self-heal and self-interconnect kind of regardless of, one company's profits or loss or, what one individual wants to charge for their storage system. We should have an open marketplace with resilient nodes all around the world that are storing that. And as we, innovate in the Web3 space, I think we see that there's demand for that. We have more people that are applying the same strategy of having an open marketplace for storage to other areas as well. We should have an open marketplace for weather. We should have an open marketplace for mapping. We should have an open marketplace for compute. And have this whole rise of decentralized infrastructure networks, DePIN networks that are growing to make sure that every individual has access to contributing to that, and they can offer kind of an open market for purchasing access to those things instead of having to go to one central provider, whether that's a central provider of storage, compute, or some other service that's aggregated out of those many different pieces of hardware nodes. And I think that's really exciting. And that's a pretty cool trajectory that we're on. And that's definitely one of the things that keeps me excited about how data connects into that as well. You kind of mentioned there's these three layers. We actually even start one layer below, which is assembling capacity, just the hardware to do storage, even before you store data into it. That's a whole initiative that Filecoin kind of went through in its first year after mainnet launch.
Did I hear that you have 10 exabytes of capacity now in the network, which is
Yeah,
which is where, the big cloud providers are basically, or were a few years ago?
yeah, it's super exciting. So there's somewhere between 8 and 10 exabytes. Definitely goes up and down depending on how much demand there is.
And an
And then there's
exabyte is 10 to the 15.
yeah, pretty cool. It's
Yeah.
large scale. Someone yesterday was quoting um very good numbers that I unfortunately do not have in my fingertips of like making sense of how large an exabyte is because my brain does not process how large it is.
Yeah.
But it's like many times the entire Netflix library. I think it's how 1 exabyte is the total of all words ever spoken by humans, something like that.
Wow.
It's like, you know, massive scale. But of course, we are consuming that sort of massive scale. Just CERN is, one of the early Filecoin users, and they are storing all of their neutrino data. And they generate a lot of neutrino
No
data
way.
in CERN doing all of their
CERN is
boson
putting
stuff.
their data on Filecoin.
Yeah, it's pretty cool. The some of the dark matter research and neutrino labs are all making access of large scale storage services so that they can have low cost storage for these things that they in the future want to hold on to more data so they can run machine learning algorithms. They can extract more insights from the same data set that they used to just have to throw away because they couldn't afford to store all of that data with something like AWS. Um, and they also want to be able to partner with people in more different areas so they have kind of more options for when to retrieve it. And they don't have to pay centralized bandwidth egress costs from AWS as well to be, having to retrieve the data and then run calculations and compute over it. And so that's where we get to that third milestone is like data really matters when you want to kind of make sense of it or apply it to a new problem. Sometimes you just want to retrieve it and look at your photo or, someone wants to load your website or something like that. But a lot of times now we're seeing the rise of edge computing where you want to bring the compute to the data set itself and run, a search algorithm or an indexing algorithm or a transformation over top of a large scale data archive. And then only return a much smaller result that is what you're looking for, or
Is
a
that is that
transformed model.
is that primarily, in the case of user data, I could see that being really relevant for privacy and like kind of giving us, not leaking more information than you need to. But is there, what are reasons folks might want to do edge computing outside of that? Like, do people want to do that in the kind of scientific computing space also?
Absolutely. Yeah. Not just in privacy, but also just, maybe I have like massive large scale neutrino data and I'm trying to sort through all of that data and run some sort of search function that's pulling out just the examples of you know particles doing this specific thing that I'm looking for and then just return me that subset, right? And so I don't want to actually retrieve all of my exabytes of neutrino data. I just want a smaller piece and that's what I'm going to now go study and analyze and do a deeper dive into. And so there's, I think, lots of DeSci use cases of, hey, I want my compute and my storage to be located at the edge, kind of either more adjacent to collection or in locations in the world where I can store it cheaply and resiliently across many different areas. And then I want to centralize and locate subsets of that data for like deeper introspection and study, near the researchers who are kind of doing doing the next steps with that data. And
Yeah,
so,
because
yeah,
when we're talking about large data sets, like how you kind of massage and maneuver around the data is as big of a problem as, you know, analyzing it when you have it in one place. And this is kind of making me think back to, you know, Hadoop and MapReduce, and a lot of the breakthroughs back then were like, how do you compute over this data without having to bring all of it on one server, because you'll never be able to do that.
exactly. I'm really excited. If there's someone who's working on a version of MapReduce that works over top of large scale decentralized storage networks, come talk to me, because I think that's going to be a really interesting use case for large scale scientists who have neutrino data across a ton of different storage providers.
That's very cool.
Yep.
So maybe let's make it concrete, just so folks who might not be as familiar also know exactly what we're talking about. So I think when I first came across the larger sphere of projects, it was IPFS at the time, which already blew my mind. It was one of the coolest things I'd come across. But if I remember, you can correct me. But the idea is to kind of content address data is kind of like one of the big kind of pillars, one of the big ideas in there, which is rather than refer to data by the location of where it's stored, which is the general kind of DNS and IP address kind of mapping that we use in the web. Think about what the content. I mean, you'll do a much better job describing this, but I'm curious how you would describe the kind of like arc that the larger project has gone through, and what the kind of like big moments there have been, and where we are today.
Yeah. Yeah. To summarize history quickly, because Protocol Labs is just celebrating its 10th anniversary. So been around for a long time. First, there was IPFS. IPFS was all about enabling content addressing and enabling its usage in decentralized applications or peer-to-peer file sharing, making it so that regardless of who served you the file, you'd be able to validate, yes, this is what I was looking for and asking for, and create a whole uh, file system. The FS stands for file system, around accessing and storing content based on that content ID. After that came libp2p and IPLD, which were kind of abstracted out of IPFS as the generalized peer-to-peer networking layer that's actually now used by most blockchains, including Ethereum, Optimism, Polygon, Polkadot. I can keep going off. Filecoin, of course. And then also IPLD was that kind of more generalized content addressing data model, which is actually now used by folks who care about data portability more generally, even kind of outside of the peer-to-peer models. So folks that are doing federated models, but they want to be able to share data or have people be able to take out their data with kind of the same kind of data abstraction layer. So Blue Sky is using that for the data portability side of things. And then after that came Filecoin, which applied an incentive layer for taking a whole network of peer-to-peer nodes and being able to hire some of them. Hey, can you hold on to my content address data over time so that I can close my laptop, but I can make sure that my photo library or my neutrino data is still stored online. And since then, the kind of like Protocol Labs ecosystem has grown to be hundreds of companies and really evolved into this massive innovation network that's working not just across Web3, but also a number of other verticals like, pushing forward new economic models for funding public goods and other new breakthrough computing technologies. And so for Filecoin, it's really been the birth of this much wider ecosystem of many different projects, many of whom are now building on the Filecoin virtual machine, which came a year ago and unlocked whole ton of new use cases, both enabling people to program around Filecoin storage primitives, enable people to do different sorts of dexes and interesting leasing models so that they could put their Filecoin to use for storage provider collateral. And then now all sorts of new L2s are starting to spring up as compute networks that are interfacing with data stored in Filecoin or Filecoin storage providers themselves, so that you can do this directing of compute to a storage provider that has the data, or routing of a storage deal to someone who just finished a compute job and wants to store the snapshot or output of that compute job and then send just a URI to the person who might want to fetch the result in the future or a subset of the result, and make use of that. And so that's kind of the third step in that phase you were describing of going from storing to retrieving, and now there's all sorts of new compute networks that are some of them are already live. Fluence launched as an L2 of Filecoin back in March, and some of them are in the works. I just was hearing about the Swan network that's launching in 2 weeks, I think is what Charles was telling me. So a whole new set of kind of networks that are building on and with decentralized storage so that they can offer additional services on top of it, or provide things that tune it for other markets. So there's a group called Textile that's been huge part of the Filecoin and IPFS ecosystems for many years. They're building an L2 called Basin, which is focused on doing kind of caching and some amount of data availability for DPIN networks, and maybe even AI and compute networks as well. And so that's kind of like the evolution of network capabilities, and now many different on-ramps and compute services and startups that are building on and with Filecoin.
That's incredible. What have you, I mean, one of the things that's kind of most exciting about an open network like this is that there's a set of kind of incentives, like economic incentives and otherwise, like reputational incentives too, where if you kind of, in the abstract, if you remove, say, Protocol Labs or any other single organization, the incentives are designed such that this marketplace would kind of, organically evolve and still tend towards producing this like good output that we're looking for.
Okay.
What have you learned about like what are the incentive structures that you've built into this network, and how do they work?
Yeah. Filecoin has a ton of really interesting incentive structures. There's obviously the block reward incentive. Filecoin is a combined proof of work and proof of stake network. So it takes a lot of keys from Bitcoin and Ethereum, which were both proof of work when Filecoin was being designed, but added on the idea of collateral so that you could have confidence that someone who's committing to storing your data has their skin in the game, that they're going to complete the full storage contract that they've signed up for. And so there's both the block reward that incentivizes storage providers to bring their capacity to the Filecoin network. And then there's an increased block reward for folks that store useful data into their capacity. And so that's the Filecoin Plus program that provides that kind of like additional kickstart of, I'd rather have my capacity being utilized than just put capacity on the network and never store any data in it. There's a couple of other networks that did model themselves that way, and they just, chewed up storage hardware and never stored data for anyone. And that's not the purpose of Filecoin. Filecoin aims to be kind of a robust foundation for humanity's information. And so it wants to store and be useful in those areas. We're actually seeing a pretty strong trajectory now towards increased storage fees. So there's a couple of groups that are not just paying for their Filecoin storage, which is great, but they're paying a premium because they're getting more verifiability about how that data is custodianed over time. They're getting the provenance through the content addressing, and they're getting the kind of like, ability to retrieve from many different parties in the network instead of having a single storefront that gets to, set your retrieval prices. And so that's been like a cool trajectory for the Filecoin network. And that is also an incentive in and of itself. People paying for the service that these storage providers are providing helps them compete against a real open marketplace to offer their services. There's a couple of other incentives. Obviously, there's now the FVM. That's a whole programmability smart contract layer. Folks who build new services on that layer can take a cut of the proceeds and transactions that flow through that. People who are building L2s both can, have the incentive to bring in more value and more users, but that also benefits, the Filecoin network as well, because the more data that is generated by those L2s, the more transactions, the more value that accrues in Filecoin L1 as well. Let's see. Also, from maybe an economic, like network community perspective, there's hundreds of teams in the Filecoin ecosystem. There's actually was a blog post that I helped work on a couple of weeks ago, talking about the different teams that are just focused on building Filecoin public goods. So people that are building core implementations. There's 3 different client implementations in Filecoin built by entirely different teams, or building like storage provider software, or custodianing the proofs system, a number of other different, open source components that are all needed to kind of accelerate and improve this wider market to serve different use cases. And there's now a Filecoin retro PDF that runs that helps reward all of those different participants through kind of like open badge holder voting. There's also a number of different kind of like prospective and like grants programs and funding programs that help teams who are building in this space build open source building blocks that they might not even have a business model around, that's incentivized to make Filecoin stronger. And so Filecoin Foundation runs a pretty good grants program that has funded a lot of those. And there's a couple of other kind of funders within the Filecoin ecosystem that contribute to those projects. I feel like I could talk. I guess there's one other really interesting thing, and I'll shut up about incentives because it's an area that I'm very interested in. There's also the incentive around something that Filecoin implemented was called the baseline. And so this is kind of setting a target or goal for the Filecoin network in terms of hitting different benchmarks in terms of how much storage capacity and how much actually utilized storage the Filecoin network hits. And it's roughly trying to estimate how, like using Moore's law, how much storage hardware and how efficient is it in the world? How costly is it? And therefore, how can you expect the Filecoin network to potentially grow over time? And based on whether or not...
How do you derive that curve?
This was set based roughly on past data at the time that the network launched. So it's part of the Genesis crypto economic primitives that were set of like, great, here's your curve out into the long-term future. And that creates kind of cooperative competition for all of the members of the Filecoin network to try and reach that curve, because you get the closer you are to that, the more block rewards that you get up until you hit that baseline. And then it's just, equal block rewards being split among everyone. So it creates this incentive whenever you go underneath the baseline to collaborate with each other and bring more members of the community, because every new person that you bring into the ecosystem, the more you collectively earn towards that maximum. It also means that if Filecoin isn't hitting all of those targets, less Phil get minted over time. And so it's also a mechanism to kind of be efficient with the network's resources so that it's paying for the value that's actually being created by members of the ecosystem over time. And so that's, a cool mechanism. I haven't seen anyone else.
It's like a self kind of propagated and enforced, like milestone based, funding mechanism
in a totally decentralized ecosystem made up of totally independent parties who then coordinate to try and grow the value they're creating.
Yeah. Wild. And so this has all been over how many years has all this stuff happened?
Wow. So I think the original Filecoin white paper came out in 2014, along with the IPFS white paper. But, energy was first put into building up IPFS as an open source project and community, getting those building blocks. Because if you don't have IPFS content addressing and peer-to-peer networking, you're missing some of the key building blocks to go and make Filecoin happen as well. I think the second white paper that was much more detailed, had a much stronger economic model around it, was 2017. And then Filecoin mainnet was October of 2020. So smack dab in the middle of COVID lockdown days, which was super fun for the many different teams involved in building all of the different client implementations, supporting the mainnet launch, all of the things like that. And then since then, there's been a couple of major upgrades that we've worked through as a community. There was kind of within the first year, Filecoin was just at massive capacity. We were like the entire ecosystem was DOSing the chain. We were constantly at like 120% of like what the chain could hold from a capacity perspective. And so there was a big initiative to scale, kind of do snark aggregation so that we could massively expand the capacity of the Filecoin network. And so that was a kind of a big milestone back in, must have been, I think, July of 2021. And then there were a number of initiatives around like really improving the storage and onboarding journey in Filecoin. So this is really getting the flow working well for large scale clients. So this is Internet Archive, USC Shoah Foundation, UC Berkeley. It's around the time that at least CERN was a glimmer in some storage provider's eye of bringing them into the ecosystem. And so there was a lot of initiatives around like building better tooling, building that client onboarding experience, scaling the amount of data that was able to flow through the Filecoin ecosystem now that we've kind of unblocked kind of some of those chain capacity issues. And then I think, I would bundle the next big phase was unlocking Filecoin virtual machine and, enabling this whole ecosystem of programmable storage, which unlocks really cool things like data DAOs, communities that are collectively governing a collection of data, maybe monetizing that collection of data for people who want to run compute jobs over it, and doing so for kind of the integration. Now we start seeing L2s, which I think is a really exciting use case. And we're also seeing kind of the interconnection with compute networks, DPIN networks, AI networks that want decentralized, robust storage. There's also actually, even parallel to that, a whole thread around the kind of growth of social networks and like gaming, Web3 gaming, that also really care about content addressing. They have, sometimes quite large, video assets or kind of like in-game, world models or things like that. Mona does a lot of really cool virtual worlds that are all stored on Filecoin as like these kind of robust renders and NFTs. And so that's also, I think, a really interesting area that, entire businesses now exist applying this and making it kind of fully integrated into different vertical applications.
Wild.
Yeah, crazy days.
This is it's like so impressive to hear about all of these different projects, especially because that at the time when you're looking at, say, designing the inflation schedule and these milestones and how the fill is going to get released, or you're doing any of these things that you talked about, building the Filecoin virtual machine for the first time, or sketching out what IPC and layer 2s on Filecoin are going to look like very few of these have kind of predecessors out in the wild. And, there's no playbooks that you can look at and kind of derive what you're doing based off of. There's often a mix of, even defining what the problem you're trying to solve is, research, engineering, like building it into this production setting where a bunch of different client teams are working on these things. It's being used around the world. The whole thing's kind of insane. And and I'm curious, what have you learned about what it takes to do this? I think even when I look at what an individual startup building a product that, is running on a server and is solving a well-defined problem, that's already like a very difficult thing to do in the world, because you're going from something not existing to something existing and working and solving real problems. But you're doing that at an entirely different scale on like hard mode. So I don't know what, and you've been consistent at doing it, right? So how do you do that basically?
I would say always be looking at your plan and roadmap and evaluating, is this still the right trajectory? Has new information come on the scene that I need to be incorporating into my plans? And sometimes you end up down a pathway and you're like, well, if that pathway had been a thing back in the day when I was making this decision, like I would probably be over there, but that wasn't an option. And we're here. What is the best way for us to like adapt with that new information or understand how those pathways might move together in the future? a lot of times that's like making sure that you have confidence and you can justify your decision making of like, this is why this makes sense. This is how this is going to fit in. Sometimes you end up with an entire ecosystem following you on, something like having a shared peer-to-peer networking library, and then you get to share the lift across many different networks and organizations that are all depending upon those same building blocks, which is great. And sometimes you're like, well, here's how we've done it here. How do we get to share where there is something in common? And then how do we get to capitalize on maybe where we've done things differently, or the different kind of like benefits that exist in how we've done things? One of the key decisions for FVM was deciding to be EVM compatible, and doing
Right.
EVM compatible first, but putting it all in a WASM hyperlayer so that we could do EVM compatible and then Solana and then JVM and then, a WASM interpreter. And we could do all of those things from kind of an interoperable base layer. I think a lot of it comes from thinking about like the open source community and how do you find these pathways to like smooth upgradability and design for upgrades proactively so that you're trying not to lock yourself into the current state of the world. Because, Filecoin, first white paper, 2014, a long time ago. A lot has changed about the ecosystem since 2014 when Ethereum was like first launching. And so that's a different trajectory than, things that are just getting started and being designed today. We're like, great, where can we reuse and harness what already exists? Being Ethereum compatible means that you can just pick up and move your smart contract, or have a smooth bridge between two different networks that are both Ethereum and EVM compatible really seamlessly. And so, looking where are those, network effects or opportunities for shared collaboration with
It's
groups.
I feel like what you're saying about like I have noticed this theme of future proofing what you're working on.
Mhm.
And this it's also interesting because in this there's so much uncertainty and such an open design space where if you bake that future proofness and optionality into your core design,
Mhm.
then you can move forward with it really quickly while knowing that you're not creating any irreversibilities.
Yeah,
So it's like a really interesting way to blend being able to move fast with being able to adapt as new information comes out.
exactly. And when we were initially doing the, lead up to Filecoin launch as a community, it was like terrifying. So it was like, oh my God, we're going to launch this blockchain rocket ship and it's going to be out in space and it's going to be impossible to, you have to send up a new rocket ship every time you want to make changes to it. And nowadays, I don't think people see network upgrades like that at all. Like they're, much more common and scheduled and run of the mill. Making large changes is still pretty tricky. But there's, even FVM, that was a pretty large upgrade that many different teams worked on to make it a reality. And, was able to, all lean into that upgrade together. And then I think it was, efficient compared to many other groups that have gone through the process of adding a programmability layer and runtime. Um, so I think, finding, modeling yourself, like, all of Filecoin was modeled from the get-go with the concept of these, different actors. And we even have a cron layer in Filecoin, which I'm not aware of many other networks that literally have their own cron, but this is what you get when you have a network that's built by, actual distributed systems engineers who are taking all of those computing lessons and being like, great, let's, have cron that's checking the different storage providers for and executing different updates at that layer instead of them all having to happen in their own smart contracts. And so, those are some of my lessons and takeaways. Be real, we haven't always gotten it right. Sometimes we end up on a branch where we're like, this we thought that we designed this modularly or we designed this for change, but we actually, have an assumption or kind of like an opinionated building block that's a different trajectory than where other people in the network ended up. And now, how do we either harness the benefits of that or move to something that's going to be more compatible or used more commonly across other ecosystems? So one of the things right now is like being EVM compatible is for FVM is awesome, but how do we by default, grab some of the new improvements that are happening around ZK EVMs or account abstraction in various different networks? Like, we don't want to rebuild all of these kind of building blocks. We want our special sauce to be augmenting them with decentralized storage and kind of interfacing between storage and compute. And so all of those kind of like smooth pieces, how do we enable them to come and interface smoothly with the Filecoin network without having to reinvent them ourselves? And so that's, but we're building upon a foundational layer that started long before these other networks existed and created their models. And so figuring out ways to adapt and pull out bad decisions while still trying to be able to execute quickly takes work and takes engineering flexibility to find a way to remold your system to have that cross compatibility to grab other people's ideas.
What does that look like in the case of, say, EVM compatibility, or how that? Because I feel like it's an interesting case study of it's a very big project, and like you're saying, Filecoin's been around for a really long time.
Yeah.
Yeah. How, like, can you take me
Yeah.
into the thought process, the trade offs, the decision making, the roadmap? Like, how do you see this project?
Yeah. So yeah, when FVM launched, it EVM compatible, but EVM compatible as of kind of a snapshot. We use precompiles to expose the built-in Filecoin actors for storage capabilities and things like that to smart contracts that are written in Solidity. Um, and one of the things we didn't support by default because it was deprecated in EVM at the time was like legacy EVM transactions with our legacy. And we're like, great, we're not going to support those. Turns out everyone is using them. And so
Oh
now we're
no.
like, great, okay, now we have to go and implement support for legacy EVM transactions. I think we started from a Rust EVM implementation that we could, pull into Filecoin and start running in our WASM, FVM runtime. But there's definitely also a lot of the building blocks in Filecoin we had to connect to that. How is the gas model going to work? How, what APIs are we going to expose to smart contracts? Then we'll start depending upon them and need to be, versioned or become harder to change. For EVM compatibility, a lot of that is already pretty standardized. So there's a lot we can lead on, but it also requires a crap ton of testing to make sure that you're holding all sorts of invariance constant. Obviously we're using Filecoin's gas model. We're not actually charging gas in Ether or live, I guess. And so we're having to abstract some of those components to make sure that they bridge between what smart contracts expect and what is actually happening under the hood in the network. And so we pulled examples, like multiple. We looked at what Near had done. We looked at what Polkadot had done. I think there were a couple of in-project Ethereum compatible networks at the time that weren't quite yet launched. Solana was working on one, which might actually be live now. Polygon was working on one. And so we definitely looked at what were best practices at an ecosystem level and did our best to make compatible choices. Now looking at how they just I think WASM time, which is the kind of WASM library that we use for the WASM hyperlayer side. They just announced a WASM interpreter that's actually designed for smart contracts. And so, okay, cool. That might be a new interesting thing to add alongside our EVM compatible layer. Now we can have a WASM smart contract programming layer. And part of the design there is like, well, if you even put all of the EVM runtime aside and someone creates a new thing that is better than the EVM or iterating upon it, we can add that as another layer, right next to the original in the Filecoin runtime, in the FVM runtime. And so that's part of our, we at least have one layer below that, even if, EVM doesn't end up being the be all end all bet for the space, then you can go one layer down and have, hopefully a layer of modularity or the ability to have a second version that there's space designed in your programming environment for. So that's, I think, kind of how we're thinking about it right now. We want to put in the resources that enables kind of a thriving ecosystem around EVM, but we also want to be looking at where is there the most growth in the smart contract community right now, and how do we join forces with some of those groups to enable them to be kind of innovating and bringing those innovations into the Filecoin ecosystem as well.
Into the Bytecode is sponsored by Optimism. The Optimism Collective is building the open source modular software project known as the OP Stack, which allows developers to run layer 2 blockchains while also addressing key governance and economic challenges in the wider ecosystem. Optimism is also leading decentralized grants experiments like retroactive public goods funding, which recently granted 10 million OP to projects across developer tooling, infrastructure, and education. More recently, they had a major milestone by adding Coinbase's blockchain Base to also be governed by Optimism governance and also contribute a portion of their sequencer revenues back to the collective. I've known the Optimism team for many years and know that they're dedicated to both scaling Ethereum and extending its ability to build better economic structures. So, if you're interested in learning more, whether you want to build something new or you want to apply for grant funding, then I encourage you to check out Optimism at optimism.io. Totally. I mean, that's also one of the things that's exciting about this kind of roll-up centric roadmap for Ethereum is that different roll-ups can experiment with different runtimes, and you can have this kind of more of a marketplace of different ideas that can be experimented with and just move compute from being on this one single mainnet to these different networks.
Yeah, and that's exactly what you've mentioned IPC a couple of times, which stands for interplanetary consensus. But this is the L2 scaling technology that's been kind of been built around the Filecoin ecosystem. It definitely has applications beyond it as well, but has kind of been focused first on compute, data, and kind of more robust infrastructure use cases, because it's specifically thinking about, all right, well, what if we take a very modular approach to what is the chain? So instead of having one single L2 that's like exporting all of its consensus back to L1, let's enable that L2 to have its own modular consensus, use the L1 for security and checkpointing, but be able to have its own proof of stake network, proof of access, proof of whatever, proof of authority. It can run its own consensus in L2, and it can even have multiple different L2s. So it can spin up different L3s. It can have a whole network of subnets, is what we call them, where you're actually composing across, spinning it up kind of like new processes or new VMs, so that you can have one for each different user that your data network is serving, and have this very lightweight model of what a new blockchain runtime can look like. And it's really oriented towards, hey, if we look 5-10 years down the road and we imagine people are, using Web3 like they use for Cell today, how would blockchain look? What would it look like to spin up and run a new blockchain network kind of the way that you would have programmed today? And so that's kind of like the initial design ideas that went into IPC, and is now, powering Fluence. It's going to be powering Basin and a number of other networks that are building with Filecoin. And the aim there is that, it's very seamless to work between these different networks. And you can be, calling and doing message passing between networks pretty seamlessly, so that each new network that comes on, the whole swarm of subnets gets stronger and more capable, because they can access even more capabilities across the network. And so, I strongly agree. You want many different networks that each bring their own capabilities and that can focus on doing that capability really well and harness each other's strengths.
So you've been very intentional about certain parts of the kind of how these subnets interface with each other being predefined, and because of that interoperable, say how they do message passing, but certain other parts like how they get to consensus within themselves, they're kind of like free to do that however they want.
Exactly. So, literally aiming to make, I think right now these are all comment BFT. So they're all kind of harnessing the modularity there of the node type that's being run in these subnets. But the aim is to make the consensus module itself pluggable so that you can deploy your own consensus actor that uses, your own algorithm of what makes sense for, your subnet, your ecosystem, and that you're, able to use the L1 or parent network, because maybe your parent isn't an L1, maybe it's an L3 or an L4. But you can harness your parent security by, storing collateral that can be slashed for bad behavior, at that parent level.
So this future of Vercel, a Vercel that's able to deploy kind of decentralized applications as smoothly as we can centralized ones. What are you actually envisioning when you think about that? Like, aren't, client server applications? Like the data is kind of distributed in this open network. There's compute that's being run on that open network that's, again, fault tolerant and redundant, and it's not happening on any single server.
Mhm.
And then there's maybe specific clients that kind of surface that and visualize that to the user. Like, what are you actually envisioning there, and what are the sorts of like, what is a concrete application that we're talking about? Like, are we talking about an internet that looks kind of fundamentally different in that, let's say, if I'm using a social, like for social networks, it's easier for me to visualize this transition, where right now we live in a world where the user data lives on, you know, uh, X.com's servers, and I go to the X.com product, and that data is getting surfaced to me as a user. I interact with it. It gets, it says client server model mediated
Mhm.
by
Mhm.
HTTP requests back and forth. If we're talking about a decentralized social network, it's like a totally different thing, right? There's multiple products on top of a shared protocol. Um, yeah,
Yeah,
what does that
generally,
world
like
look like to you?
I can speculate. I think there's lots that we'll learn by actually starting to bring it into instantiation. Um, it's funny when you're describing it. I'm like, we should call this the cloud. Why did we already use the word cloud? This actually is
Right.
what makes sense for that terminology, because um, I think there are a lot of parallels, right, into how we've seen the Web 2 model evolve. Except instead of these being centralized businesses and services that each are holding, your data or your, identity in centralized accounts and walled gardens, this looks more like, maybe X.com is running their own local servers. Maybe they're actually exporting that to AWS, that is an EC2, that are running their compute and storage systems. And they're just actually a front end that is combining together these set of
Totally.
interfaces. So I think that could look like you have a subnet for your social network for Faircaster, and that's executing as its own subnet, and it's calling out to storage within a different subnet that's providing it caching, and maybe it's actually storing some other things on a different subnet that's more optimized for video and transcoding with live peer. And then you have another subnet that's being used for some of the large scale compute jobs, and maybe it's doing indexing, maybe it's doing other things, maybe it even has different compute networks it's using for when it's doing compute over private data that you want to keep, fully homomorphic encrypted and, not visible to anyone who might be observing that network. And so I kind of see it as like a swarm of processes and capabilities that are actually being composed together across many different subnets that are able to interface with each other, pass messages, kind of compose and execute. And then as a user, you're kind of, you know, having your entry point into one of those that's maybe powering your decentralized front end, hopefully that's stored on IPFS, so that you're using your, Blue Sky or Farcaster or whatever it is. And then you have like a whole decentralized network with different subnets that might be, you know, uh, made and have their own communities that might be powering many different, social networks, just with that kind of one storage system or that one compute system, but that you can break out and optimize those different subnets instead of trying to make just the Farcaster, network do all of those things and all of those capabilities all by itself. There should be that optimization of, great, I'm going to harness this compute network, I'm going to harness a storage network, but that should be happening directly at the blockchain level. And the kind of hiring of services should be as simple as sending messages between smart contracts instead of, someone on the Farcaster team having their own AWS account where they're actually storing all of their content so that they can, serve the Farcaster user base, right? That's just, leaning back on centralized systems and centralized points of control to then end up serving a decentralized network and ecosystem and product. And so it's kind of looking at what will it look like to have decentralized systems all the way down and decentralized primitives that allow them to, specialize, compose, and interact with each other without having intermediaries.
Hmm. What do you think the ramifications of that are for like business models and
Uh,
where power accrues, what the kind of landscape of products, companies, all of this looks like?
Yeah. I mean, I think the first thing is we need to stop treating gas as a precious resource, because in that model, like having the amount of gas in like some overall blockchain ledger, like you can just spin up a new subnet and you can have, subnets at some of those are going to be global subnets. Some of those might be just a subnet that's running, in the data center to do some process. These networks might be ephemeral. And so treating a blockchain as something that every network needs a strong community or, needs its own token, needs its own this, that, or the other. Like, no, some of these are going to be like, I spin up a new one of these every time I have a new process to execute and a subset of nodes join it, execute that process, checkpoint it back in the parent, dissolve. And so I think there's definitely some ways that we've, built up businesses and economies in Web3 today that, might exist at some layer of the stack, but we'll see many subnets that don't have that same kind of like, uh, you know, ecosystem or branding or hype around trying to get everyone to think that this subnet in particular is really cool and you better get in the boat now and speculate around. And it's like, no, come on, I'm just doing compute for you, man. Buy my process. I will, execute this, valuable good and we'll all continue on our way. And this will be a building block that can power, economies, the internet, infrastructure that people depend upon and pay for. And so I think that's a really exciting future for us to be building towards, which is one where kind of the value that Web3 creates is really based on the services that we're offering to people and kind of like, how they are getting value out of those services directly, instead of people speculating on whether or not, this 3-letter word or that 3-letter word are going to be really cool next season or something like that. And so I definitely think that creates a change in the Web3 market. I think when we compare that to the cloud today with these like centralized behemoths, it definitely creates a, more openness for anyone to like come in and participate into those because those are, most of them are open access systems. Maybe if you don't happen to be in that data center, you're not able to join that subnet to execute that compute job for that, local bank or whatever it is that's running things locally. But you then have this kind of like openness for how resources can be utilized in the ecosystem that has, less of every different business having to go and buy and assemble these for themselves.
How do these subnets keep like people out? Like if it's a subnet in a data server, like how does that reason about who's inside this firewall and outside?
Yeah, I mean, it probably depends on the consensus of your subnet, right? So if you're like a proof of access, then you got to be on the access list. Otherwise, you can't participate in my subnet. If it's a proof of stake, you got to have some stake if you want to participate in my subnet. So how do you get access to that stake, and how much of it do you need to be able to start participating? There's different proof. Maybe you have subnets that are restricted to a certain geography, so you got to be in the U.S. or in US East or in, the local region. And for that, you get really interesting things about, okay, well, how do we do that in a decentralized context? There's a couple of different networks. Foam Network, a couple of others that are trying to do proofs of location so that you could gate people based on like their ping time to a certain point of the world. There's a couple ideas that have been done around, hey, you could actually do this with satellites, so you could do, literal speed of light calculations to figure out how close you are to a different part of the world with, satellite testers where you know that no one can go and interfere with that hardware because it's literally in outer space, orbiting the Earth. And so, I think that becomes really interesting because you can be like, great, I have a requirement that all of this activity is being done in a certain region or within a certain time to execute. So I can have sub-second block times where all of the nodes participating in this can actually communicate with and come to consensus on some block because they happen to be geographically close to each other. And so I think, that's the cool thing about subnets with their own consensus metals. They can innovate. They can do something new and different. They can kind of set their own rules.
So in terms of like, I guess we can think about it in terms of both being able to read and write to the network. So the consensus gates who can write to the subnet, because it might be proof of access, and it says if you're on this white list, you can. If you're not, you can't. But also on the read side, also the subnet can kind of choose to what degree it reveals its inner kind of peer-to-peer network to the outside,
Yeah,
because
yeah,
it can, when it checkpoints onto the subnet that's above it, it can either put a zk proof on there, or somehow abstract
exactly.
away what it's revealing.
Yeah. I think
And
you'll
for
see
the
it definitely.
data layer too, I mean, the data is going to be open unless you use some kind of a homomorphic encryption or something like that, right?
Yeah, but it might not be accessible. So, it depends on how you're storing your data. Maybe you're a bank and, only people who only nodes that are located in your data center are the ones that are allowed to join this network, and your content addressing all of your data, but, none of your storage nodes are going to allow that to be accessed and retrieved by anyone else. And when you checkpoint it into the network above, you're using a ZK proof. So you're not even exposing any of the content IDs for the individual, transactions that are happening inside your bank data center, presuming that you want to be a closed and private bank about every single sub transaction. If you want to be an open bank, great. You can make those all open. You can checkpoint, the whole transaction history, and voila, you have, kind of an open data system, but you're using the same primitives each way, which I think is,
Wow.
if we're looking forward to the future and we see Web3 being this kind of layer that all of us are building upon, and it needs to have that flexibility.
So this kind of way of thinking about subnets, it makes me think of the internet, right? Of like a network of networks.
Yes.
And each of these subnets, the way you're describing it, it basically, at the one extreme, it can reduce to being a single server, right? Like it can basically give you the same functionality that you get out of running a single server in AWS today. And
Yeah.
that's the case where the consensus algorithm basically says all the only reveal the data to this one node, and only allow this one node to like write new information.
Yeah. And then
And
it's
then
just like a
basically you have
logging
a server.
process for your server. Yeah.
Right, then it's just a logging. Yeah,
Yeah.
totally.
Yeah.
And then that's like interfacing with the rest of this web. So it's very, very powerful design.
Yeah. You're trying to create as like, small and modular of a primitive as you can that can then be maximally flexible. And we're actually, as we're talking about it, and it sounds pretty cool, huh? If we are actively looking for people who want to work on and help build kind of the future of IPC. And so if you're excited about it, definitely get in touch with me on Twitter or Filecoin Slack or anywhere like that, because I would love to talk to people who are excited about this and see the power and opportunity of shooting ahead of where the blockchain space is today to build some of these kind of really scalable primitives.
Totally. I think that what's really special is that you've already built the kind of like storage primitives and network, and the protocol can reason in a very nuanced way about like what is being stored with what level of redundancy, who gets access to it. And that's really because storage, like data storage, is ultimately the bottleneck for rollups and for these like compute networks.
Yeah. And we actually, literally have groups who are like, great, I'm going to a very simplified version of data availability. I'm not like offering data availability to data availability layers because they're doing like, all sorts of complex proof related things on top of the data. And it's like, well, but you just want to make the data available, right? To anyone who wants to fetch it. Like we can do that. And we can do that for long periods of time, much more than 7 days of your proving window so that you make sure that anyone can also use that as an RPC to fetch data or to index data, and build their applications on top of. And so there's, this is kind of what Basin is aiming to do for DePIN nodes and networks, so that all of their DePIN data has a decentralized home for making the data available, and you don't end up with someone actually having a centralized point of failure because they're running the AWS account that everyone uploads their data to. But if that credit card went down, suddenly all of your DePIN nodes would, suddenly be being slashed because their data isn't accessible. And your whole network value, goes away.
Okay, one last topic before maybe a fun question or two is
Mhm.
um, the other dimension on which the Filecoin ecosystem has been evolving is organizationally. And there's been this kind of opening of protocol labs into a whole bunch of different organizations, companies, institutions. And I think you're also kind of leading this new organization called FilOz, right? I think that's how you said
Yep,
I pronounce
exactly.
it. uh, comes from open source.
Well, so originally it actually came because Jennifer's my co-founder. We both had cats named Ozzy. And
Okay,
so Oz was for that. And then we were like, well, if we actually want to hold on to this name, it really should speak to more about what our organization is about and how we're contributing to public goods in the Filecoin ecosystem and these wonderful, open source engineers and protocol designers that help, improve and
perfect.
custodian some core building blocks. And we're like, well, that Z can look like a backwards S. And that could make it be, Filecoin open source or Filecoin operating system or, the OS around things. We're like, cool, cool, cool. That makes sense. We'll keep FilOz and keep our reference to our insane amount of cat love, but also speak a little bit to the open source contributions of many people across the Filecoin network and our desire to grow the open source community and collaborate with them. We're
Yeah,
actually thinking of ourselves as like, as a public goods team that is also a carrot to get more people in the Filecoin ecosystem to dedicate time and resources to building public goods, where we work with many, not directly public goods focused teams that have strong business models in the Filecoin economy. We're like, great, you care about making this thing happen. If you dedicate resources to it, we'll partner with you to help make a new Filecoin improvement proposal or make a new building block that you can harness in your
interesting.
application. And so your time dedicated to public goods will get multiplied by us collaborating with you, and you get the building block you want, and the whole community also gets that building block. And we both dedicated time and energy to it. So we're trying to both be an incentive layer and just make the public goods happen. It'd be great.
I like that a lot. But what's been your logic behind kind of opening up the ecosystem in this way? Why do that? And what are the kind of like guiding principles you're following in doing that?
Yeah, I mean, the Filecoin has always been an open ecosystem. There were already three different client implementations built by three different groups. Tons of different storage provider groups that were around the world participating in the Filecoin ecosystem, and a lot of different kind of builders and developers. But as we've thought about how Protocol Labs is evolving as one of the many participants in the Filecoin ecosystem, really recognizing that strong, small, focused teams are incredibly successful in their long-term kind of like growth and custodianship and execution of like a focused area, making it great, making it successful over time, and also the empowering of those leaders as kind of founders within this innovation network to drive their areas and domains forward, both where they have strong business models and are looking to gain, funding from many different funding sources, or where they're working on public goods teams, where they're, working with the network to value the work that they're contributing, either through things like retro PDF or through grants and public goods funding from many different organizations. Like that is a stronger, long-term sustainable pathway for all of the contributors in an open network. And this really came from looking also at, the difference in approach between Google approaching things as kind of a centralized company and trying to innovate and do R&D through things like Google X and Alphabet, and that really not being the best way to actually make many different breakthroughs across multiple fields happen, versus Y Combinator and the many different projects that have been able to flow through a much more open network. And then comparing that to Ethereum, where you both have that openness of many different businesses to grow and succeed, and this kind of like strong network connection of like our collective work is what powers and grows this ecosystem. So like a strong collaborative nature and kind of shared mission and purpose between the many teams that are doing that. And Protocol Labs was initially started as a company, but has now grown to have like a whole venture arm, a venture studio, has multiple different verticals that it's helping create in the world. Started funding the Commons back in, I think that was 2021, maybe 2022. And that's like now grown into a really large community of many groups that are creating, building blocks for funding public goods, and it was like, great, let's utilize all of this new tooling to make sure that a network can sustainably and resiliently support itself across many different projects, and not be trapped by how a single organization has to like prioritize and organize and execute things. And so part of that evolution has both been to let the many verticals shine, and also let the many teams that have been contributing to the Filecoin community, each of them really focus and execute. And FilOz is one of those many teams who's we're focused specifically on kind of core protocol evolution, custodianing the Lotus project, and then doing a lot of kind of knowledge sharing and community building within the wider development and design community in Filecoin. And hopefully building many bridges into other networks as well. We spend a lot of time also collaborating with folks that build on top of libp2p, or that want to bring storage capabilities into their networks. And so that's a big kind of like collaborative space as well. And so kind of the long-term evolution there is just thinking of what is the right structure that's going to be resilient, that's going to best, harness and grow to accomplish computing breakthroughs over time.
Well said. Makes a lot of sense to me.
Awesome.
How are you doing? Are you ready for more of a fun question?
Yes, fun question would be good. Let me drink another sip of my matcha.
Oh, nice. They have matcha in Iceland.
Oh, we import it.
Fair.
From Amazon, because Amazon is not a thing here.
Oh, nice. We get used to these conveniences in life. Amazon, I mean, as much as we want to kind of hate on AWS, Amazon, the retail side is pretty incredible.
100% agree. I really appreciate my Prime subscription. And one of the reasons whenever I'm in the US, I'm like, I can do so much. I can get so much without ever leaving my house. Amazing.
That's very true.
Awesome.
Okay, so maybe to kind of just diverge and go off on a potentially different direction. We were talking about this a little bit before we started, but we're both going to be at Edge Esmeralda, which is a kind of pop-up city gathering as a continuation of some of the ideas in Zuzalu, folks focusing on different frontier problems, moving the world forward in different ways. And I thought maybe a fun question for you would be, if you were going to give a talk at Edge Esmeralda and you had time to really kind of like pull your thoughts together and think about what you wanted to share, what would that talk be about? And if it couldn't be about anything that had to do with Filecoin or what you're building there?
Awesome. I'm so excited for this, and there's a lab week that's happening there for this new vertical inside the Protocol Labs network, which is around field building, especially in AI, brain computer interfaces, whole brain emulation, and neurotech. So I think if I had enough time to prepare, otherwise I would let other people who are, actually spending their day to day thinking about these problems, drive the show. But where I would be really excited to be part of a conversation at the very least is around the intersection of education and some of these breakthrough technologies. I had a couple of really great conversations over top of Prometheus dinners for the last couple of months about how might we use some of these new technological systems, whether they're, AI chatbots or, brain computer interfaces that can give us more introspection into what's happening in people's brains in situ, whether in a learning environment or in an ongoing conversation, so that we can more deeply understand how our brains kind of process new information, how different kinds of brains learn differently. Because I really do think that we have different kind of operating systems for how we process information and parse it into learning. Some people are, much more visual, some people are much more auditory, some people have to talk about it in order to gain it. And I think that might show up in the neurotech hardware that we could use to actually help people learn faster. And so I'm very curious, thinking about it from an education angle or a teaching angle, what might we use as a feedback tool? And then how might that accelerate our, capacity as a species to learn new fields more quickly or learn how to learn more efficiently for ourselves, and build up new techniques that can, help accelerate our ability to solve problems more generally as humans, not just as, delegating those problems to AI, but harnessing technology for us to solve problems more effectively. And so that's an area that I would be really excited to, probably look at it a bit from my ed tech background of like, how have we used technology in the past to enable, teachers and students and, maybe apply that to like, okay, well, how does Montessori versus other more traditional learning types, how do they introspect and use tools? Like I grew up at a Montessori school learning how to use an abacus, because that was one of the things that was in my Montessori classroom. And we learned our initial addition tables on an abacus. And, how might you think about the equivalent of an abacus for brain computer interfaces or, you know, neurotech augmentation technologies? So that's what I
How
do.
how do you what is learning? Like what do you think is actually happening in our brains? And why isn't an abacus effective at doing that?
Mm. Um, what I think is actually happening, you're forming new connections that encode information, like you're updating, I guess, bits in a hard disk somewhere. You're doing that in your brain, but very compact, very interconnected, and probably pretty efficient at encoding new information. I think, generally it would just be interesting to see how maybe different areas of the brain light up. If we can pull, reasonable information out of those areas, we can see whether or not you're, parsing information. And then we can even maybe exchange some of those mappings between people or export some of those
Whoa.
mappings in a really interesting way. Um, how I thought about applying this was like, well, imagine you're learning something uh, that's very, very 3D visual. It's very difficult to put into words. Like this is the main way that we communicate is by, flapping meat at each other. And the other person hears the vibrations of the flapped meat is like, okay,
Very
cool, great.
inefficient.
Now I've connected some new neurons in my brain. Sounds good. It's like, okay, well, what if, instead of that, you're directly going from mental systems into visual systems without having to pass through, a verbal or, written pathway so that I could go straight from, thinking about and imagining what my game would look like to, the AI directly connecting that into a 3D mock-up of the virtual world that I'm describing, and then I can iterate on it and visualize it from there. I am not a super visual person, so that probably wouldn't work super well for me, but I know some people who are, who just have that image in their brain, and then they have to spend all of this time with
How
text and other interfaces to try and make it a reality.
how does your mind work? Like, how would you describe how you kind of think?
I have the most unfortunate circumstance, which is I think by talking. So I either need to be talking to someone or I need to be talking to myself. Sometimes I can do this by writing to myself, but that's how I process. I think it's much better if you can actually do it all in a dialogue inside your head. Unfortunately, it doesn't work for me. I actually have to
So you're
verbalize it.
bound to the meat
Yes,
flapping.
I
That's in the
know.
critical path for you,
I know.
unfortunately.
But I'm excited for other people to be able to harness maybe some of the visual things. And I would also be really interested to just like, can you imagine sitting inside someone else's head and seeing how they parse information and the
It would be
insights they're
awesome.
able to grab from data that your brain just doesn't do? But maybe you can gain that skill set or that technique. You could, your mirror neurons could mirror the way in which they're actually processing that data. And maybe I'd learn to be a visual person who could, hold a picture in my head and then instantiate it into a digital game. So I'm just really excited about that area of the world and how that might empower us as humans to just be infinitely more creative and share our capabilities with each other in just like a much higher bandwidth way of collaborating. But that's like very futuristic. So I'm also really excited to bring that back to reality of like, okay, how do we do like the very MVP test of what that might look like? How do we apply it today with maybe, we have five, neuro helmets that we could use to do some very simple, like, um, you know, visual activity and then see how different brains are processing that. Maybe we can do that with enough different people that we can start categorizing and we can see where those commonalities show up between people understanding and not understanding the concept, people who have, self-described visual versus auditory versus, spoken learning types or styles. Like I would just be really excited to do some very MVP research around that because it just feels like this whole field has so much opportunity within it.
100%. Well, I feel like we're at the edge of another whole rabbit hole, and it's
Oh
probably
yeah.
wise to
We'll leave
to
that
bring
one
the
for Edge
conversation.
Esmeralda and all of the wonderful humans will meet
Totally.
there to field the conversation.
Thanks so much, Molly. This has been awesome.
Yeah, it's been super fun. Thanks, Sina.
Hey, I'm going to make a small ask here. If you've been listening to these conversations and want to support what we're doing here, I would really, really appreciate if you could leave a rating and a review for the podcast wherever you're listening to it. This might seem like a small thing, but it will really help other people also discover the show. Thank you. I'm grateful to be able to do this and look forward to being here together again soon.